Suppose that I have functions or a function f of x, y that depends on two variables, and I want to find derivatives. Well, I have a function of two variables, so to find derivatives I'm going to have to do it with respect to one of the variables at a time. And what I'm going to do is always think of the other variable as a constant. So suppose that here's my first example. I have f of xy is equal to x squared plus xy plus 10y squared. So suppose that I want to first find a derivative with respect to x, in this case a partial derivative with respect to x. Then what is going to happen is that I will go term by term, and I will think of y as a constant, and I will differentiate my x just the way that I'm used to. So if I have x squared and I differentiate that with respect to x, right, so I just get 2x. In the next term I have y times x. So y I think of as a constant. When I differentiate x, the derivative of x is 1, and so I have 1 times y. Finally, I have 10y squared. There is no x that appears in this last term, and therefore it is fully a constant. And when I take a derivative of a constant, I know I have 0. And so again, here I have just 2x plus 1. If I want to integrate now with respect to the variable y, then I'm going to think same but opposite. I'm going to think of x as a constant and y as my variable. So the first term here is fully constant term. There's no y's involved in it, so my derivative there is 0. In the second term, I have x times y, and so here the derivative of y is 1, and then I have that times the constant x. So that is x times 1. And then finally here I have the derivative of y squared, which is 2y times 10. So I have x plus 20y. You can see that these two are actually quite different, and there are exceptions. Sometimes they could be the same, but in general they don't have to at all. Now let's see this other function that I have here as an example. This is g of xy equals 1/3 x squared times the ln of y. So if I want to find the partial of g with respect to x, again I think of y as a constant, and so the ln of y is also a constant. And when I integrate x squared, I get 2x, and so I have 1/3, which is also a constant, right, times 2x times the constant ln of y, or 2/3 x times the ln of y. I also could find the partial derivative with respect to y, and for that now this 1/3 x squared is a constant, so I'll just carry it, and then I find the derivative of the ln of y, which is 1/y. And so in this case I have 1/3 x squared over y. Again, these two derivatives are different, one from the other. You also can see that, and I'll just maybe do that over here in this corner, you can see that the partial of f with respect to x can also be written as f sub x. So you might see the book maybe writing it in this way, or the partial of f with respect to y can be written as f sub y, like that. Those two are equivalent. So maybe I'll put equivalent arrows there. Okay, so this hopefully will be a good introduction to help you take partial derivatives as much as we would need them in this course.